Okay, let's be real. Everyone is talking about AI. But if you actually want to build with it, use it at work, or just hold your own in a conversation without getting lost in the buzzwords, you gotta know the fundamentals. And that's exactly what we're gonna do today. We're cutting through the noise and breaking down the 10 essential AI concepts you absolutely need to know. You know that feeling, right? You're scrolling through your feed and it's just a wall of terminology. Hallucinations, agents, RAG. If you feel like you're drowning in AI jargon, trust me, you are not alone. This landscape changes practically every single day. So that's what this is all about. We are going to build your foundational toolkit, right here, right now. We'll walk through the 10 core concepts that will actually let you build, use, and really understand what's going on in the world of AI. All right, here's our game plan. First, we'll cover the core engine. Then, we'll get into AI that takes action. After that, we'll talk about making AI smarter. And we'll wrap up with the really cool stuff, the advanced architectures that are shaping the future. Let's dive in. Okay, first up, let's start with the absolute foundation, the core engine that drives all of modern AI. You've heard of ChatGPT, Gemini, and Claude, right? Well, the magic behind them all is something called a large language model, or LLM. And here's the wild thing. At its heart, all an LLM does is predict the next word in a sentence. But when you scale that up and train it on basically the entire internet, something amazing happens. That simple task blossoms into these incredible abilities. It starts to reason, it can write code, and it can hold genuinely complex conversations. This is the engine powering pretty much every AI product you see today. So how do these engines actually read? Well, not word for word like we do. They break all text down into smaller pieces called tokens. A token might be a full word, but often it's just a fragment, like a syllable. Think of these as the fundamental building blocks of language for an LLM. So for example, you or I would see the sentence, "This is unbelievable." But an LLM sees a sequence of tokens. This is unbelievable, and a period. It's a completely different way of processing language, and understanding this is key to everything that follows. Now, because LLMs think in tokens, there's a limit to how many they can hold in their head at one time. This limit is called the context window. It's basically the model's short-term memory, and you've probably run into this. Ever been in a long chat with an AI and it just completely forgets what you were talking about 5 minutes ago? Yep, that's the context window running out of space. The progress here is just staggering. Early models could maybe handle 4,000 tokens. Today's state-of-the-art models can process over 1 million. That's a huge leap. It's the difference between an AI remembering a single page versus remembering an entire novel. This massive jump in memory is what lets them understand huge documents and entire code bases all at once, making them so much more powerful. Okay, so we've got this super powerful engine. Great. But how do we get it to actually do things for us in the real world? Well, that brings us to our next section, AI that takes action. This is the fundamental shift, and it's a really important one. A chatbot is passive. It gives you information or instructions. An AI agent is active. It takes those instructions and actually does the task for you. It's the difference between an AI telling you how to book a flight and an AI that just goes ahead and books it for you. And they do this through a continuous loop. The agent perceives its environment, like your open applications. It reasons about the best next step to take. It acts on that decision, and then it observes the outcome. And it just repeats this cycle over and over again until its goal is complete. But for an agent to actually act, it needs to plug into the outside world, your apps, your databases, your calendar. That's where the Model Context Protocol, or MCP, comes in. It's an open standard designed to let any AI model connect to any tool, which means developers don't have to build dozens of new custom integrations. Honestly, this is the perfect analogy. Just think of it like USB for AI. Remember the old days before USB? Every single device had its own crazy proprietary plug. It was a nightmare. MCP is solving that exact problem for AI, creating one universal adapter so that agents can interact with everything seamlessly. All right, so we have a powerful engine, and we have a way for it to take action. But how do we make sure its actions are accurate? And how do we tailor it to our specific needs? That brings us to our third section, making AI smarter. So a major problem with LLMs is that their knowledge is frozen in time, and they don't have access to your private company data. This is why they sometimes hallucinate, which is just a fancy way of saying they make stuff up. RAG is the solution. Before the LLM answers, RAG goes and retrieves relevant, up-to-date facts from your documents and injects them into the prompt. It gives the model the exact context it needs to give an accurate, grounded answer. Now, this is where a lot of people get tripped up. They confuse RAG with another technique called fine-tuning, but they solve totally different problems. Fine-tuning doesn't teach the model new facts. It changes the model's behavior. You use it to retrain the model so it adopts a specific tone, like your company's brand voice, or to make sure it always outputs in a specific format, like JSON. The distinction is really simple when you break it down. Use RAG when the model needs to know specific facts. Use fine-tuning when you need to change its behavior. Just remember, RAG for facts, fine-tuning for feel. And yes, you can absolutely use them together. All of this leads to a much bigger, more important idea: context engineering. You've heard of prompt engineering, right? Well, think of this as the next evolution. It's not just about the words you type. It's about designing the entire information ecosystem the model has access to: the RAG documents, the chat history, the tools it can use. The quality of an LLM's output is directly tied to the quality of the context you give it. This is a skill that is in huge demand right now. Okay, for our final section, let's pop the hood and look at the advanced architectures that are making all of this possible and really shaping the future of AI. So a standard LLM just starts generating an answer immediately, but reasoning models are different. They're trained to pause and create an internal chain of thought. They literally break the problem down and work through the logic step by step before giving you a final answer. This is absolutely critical for agents that need to perform complex, multi-step tasks. The real world isn't just text, and neither is the future of AI. Multimodal models can process text, images, audio, and video. And what's fascinating is that a model trained on both pictures of cats and text about cats develops a much richer, more robust understanding of the concept of cat than a model that's only ever read the word. So how do we keep scaling these massive models without costs exploding? The answer is a clever design called Mixture of Experts, or MOE. Instead of one giant, monolithic model, an MOE architecture uses many smaller, specialized expert networks. For any given query, a routing system activates only the most relevant experts. The result is, you get the power of a massive model, but at the speed and cost of a much smaller one. It's a huge breakthrough for making AI more efficient. So, to recap, there's your AI toolkit: LLMs, tokens, and context windows, AI agents, MCP, RAG, fine-tuning, context engineering, reasoning models, multimodal AI, and mixture of experts. Understanding these is no longer optional. It's the foundation for building in this new era. These concepts aren't just theory. They are the actual tools being used right now to build the next generation of software. The only question left is, now that you have the toolkit, what problem will you solve first?